Hello friends, followers and channel members, welcome to another video here in Microsoft Flight Simulator, where today we're going to be looking at a new feature added by the FlyByWire's team, a much sought after feature by many of you pilots out there, and that is the inclusion of the hold function for the Airbus A320. Now, holds are performed by aircraft across the globe whenever traffic coming into an airport is congested. Air traffic control may ask the pilots to hold at certain intersections or waypoints, and the Fly-by-Wire team have now added that function into the FMGC so we can easily go in and program them without having to fly them manually as we had to previously. For those of you who like to fly on VATSIM into heavily congested airports or take part in big VATSIM events where there's always lots of traffic, this really has been a must-have feature, and so congratulations to the Fly-by-Wire team for bringing this to the aircraft. In this video I'm going to show you how the holding function works and operates, how we can program them, and how we use the charts as well to assist in programming the holds that air traffic control may ask us to perform. So let's head into the flight deck and have a look. So here we are just out of London's Heathrow Airport on our way up to Manchester, and we are going to be flying the approach the Dane to Alpha standard arrival route. As we look at the chart for this, you can see as we look through we pass various different waypoints, the Trent VOR, and then as we come up to the final waypoint, which is called Dane, you can see the racetrack, which shows that there is a published hold here on the arrival route into Manchester. So what we're going to do is we are going to look at putting this hold into our flight computer, and then the aircraft will fly it. Dane is the final waypoint on the arrival into Manchester from the south. So this is the point where if traffic coming into Manchester is congested, air traffic control would have you hold there before vectoring you in onto the ILS for the current active runway. So let's imagine then that we're on our way into Manchester and air traffic control have told us to hold at the Dane holding point or the Dane waypoint. And in order to enter that, what we're going to have to do is scroll down on the flight plan page until we find the Dane waypoint. There it is. So we're going to select the line side key next to it, and you can see now that the hold function is available to us. So let's go ahead and select this, and straight away then we have the computed hold at Dane screen showing. Now, in the real Airbus there are three types of hold available. There is the database hold, there is the computed hold, which is what is shown here, and then there is the hold modified by the flight crew. Now, one of these is not available to us in the sim at the moment, and that is the database hold. Now, the database hold is exactly what it sounds like. The flight computer has a database of all the holds around the world, or in the particular area of the world that the airline flies for, and when you select a specific waypoint, if that waypoint has a hold attached to it, like the Dane waypoint in our example today, then it will automatically show the database hold there ready just to press insert and fly. Now, of course, I'm presuming Fly-by-Wire do not have access to said database, so this part has been skipped out, and instead when you enter the hold page, straight away you are brought to the computed hold page. So let's take a look at how this particular page works. The computed hold inbound course is the inbound track of the flight plan leg leading to the revised waypoint, or in this case Dane. Now, as we can see from the chart, it would normally have us flying 312. Well, our course here in the sim is 311. It's just 1 degree off. That's absolutely fine. So this is the track that the flight management system expects you to be flying when we reach the Dane waypoint. Now, we could, if we wanted, go in there and manually change the inbound course to reflect what the chart says, which was 312. The moment we do this, you can see that revert to computed is shown. Now, this is because there's a discrepancy today for whatever reason due to winds between the actual inbound course of the published hold and the inbound course that we will be flying. So the published hold has 312 and the computed hold is just 1 degree off, 311. So we can also go in and change the direction of the turn if we wanted. Obviously, as shown on the chart, it should be a right hand turn, but if we select left, we will then do a a left-hand turn. We can also change the time that we fly the specific legs. So normal holds are flown 1 minute in either direction. Above 14,000 feet, it's usually 1.5 minutes, which is replicated by 1.5. So there I've gone in and manually adjusted the hold parameters, but if I want to, I can just revert back to the computed hold. So now let's go in and actually see what happens when we place that hold into the navigation computer. As we can see, I've got Dane showing here on the navigation display. Let's come down and input the hold. And as you would expect, this is simply done by pressing the insert key. Once we've done that, let's have a look back up at our navigation display. So we just need to go ahead and find that again as that's reset. Let me scroll through and find Dane. And there it is. You can see that it has a little white arrow showing the direction of the hold that we will fly when we get there. Now this doesn't show that particular green racetrack on the navigation display as you would expect at the moment. That will show once our active waypoint becomes Dane and the computer has worked out the track by that point that it is going to fly. And I will show you that in a moment. If we take a quick look at the flight plan page, then you can see that we have Dane, we have then a right hand holding pattern, and then we've got Dane again in the flight plan. You may also notice as well that at the hold pseudo waypoint you can see that it has a speed of 209. Well, that's just there because that is actually our current green dot speed, and most holds are flown at green dot speed. They don't have to be, however, and you don't need to concern yourself with the number shown here on the flight plan page, but just in case you were wondering why that is shown to be quite a slow speed so far out from your arrival airport. Now, of course, we can technically put a hold at any waypoint along our flight route. So let's go and pop one in just here at the Tempo waypoint. I'm going to leave this as computed hold, so our flight management system has computed that when we get to this waypoint, our heading will be 329. I'm going to leave that as a right hand turn, and there we can see that we've got the little white right hand arrow showing, so that when that becomes our active waypoint we are going to see the green racetrack when we get there. So here Tempo is about to become our active waypoint, so if we just wait another half a mile or so, we should see the hold that we have programmed appear on our navigation display. And there it is. So Tempo becomes the active waypoint and the hold that we had just programmed becomes visible on the navigation display, and this is the track that the aircraft is going to fly. Now, coming down to the flight plan page, you'll have probably noticed the amber text next to the hold pseudo waypoint, and that is IMM exit, which stands for immediate exit. So we're currently in the hold technically as it stands at the moment, and if ATC at some point tell us, right, we can exit the hold and continue on our way either to the next waypoint along or direct, there's two ways we can exit the hold. We can simply press the amber immediate exit button, so then the aircraft will proceed on its predefined route, or of course we can just use the direct to function, which you'll have seen me use in previous videos and live streams. And if I just speed the video up here quickly, you'll see that the aircraft flies the hold no problem. And as a passenger, I often found holds quite exciting viewing, as you'd quite often see aircraft below you in the holding pattern being stacked up by air traffic control en route to the airport. We can also go ahead and revise any holds that we've already put into the flight management system. So for instance, we've still got the hold at Dane showed here on the navigation display. Well, if I come down to the flight plan page, I can go in and edit this hold before we get there. To do this, we simply click on the line side key next to the hold, and let's say that just for whatever reason I wanted to change the direction. Well, that's quite easy to do. We'll just key in L on the scratch pad, enter it in the turn, and if we now have a look on the navigation display as I insert that, you'll see that little white arrow changes direction. So we've still got a visual representation there of what's going to happen when Dane becomes active. Now, so far the two holds that I've programmed have been rather simple for the flight management system to compute and work out. They have been what's called direct entry holds, in that the track that we were flying leads nice and straightforward into the holding pattern. But there are different types of entry patterns available, and we're going to have a look at creating a holding pattern with a 90-degree entry inbound course over the Trent holding point, which is a lot more complicated than the direct entry we had at Dane. Now, pilots in their initial training are taught how to enter holds using either the direct entry, the parallel entry, or the teardrop entry, but that's beyond the scope of this demonstration video. We'll perhaps have a look at that another time. For now though, all you need to be aware of is the fact that the Airbus is very clever and can do all of this work for us. So let's go ahead and program that 90-degree inbound course for a entry to enter a hold at Trent. Just as before in the flight plan page, we press Trent, enter the hold page, and now I'm going to just type in 090 degrees, which of course is not a computed hold. It's one that we've set up, and once inserted, you can see that hold being drawn at almost a 90-degree angle to us given our current track. And here you can see the inbound entry that it's going to fly, as well as the actual hold once it has entered it. So what the aircraft is going to do to enter this hold is it's going to fly a parallel entry once it's past the Dane waypoint, and then it's going to enter the hold, and it'll just sit there of course until we tell it to exit. Now, this is some incredible programming from the fly-by-wire team to have all the different entries, the direct, the parallel and the teardrop offset entry, all working seamlessly in the aircraft. So big thumbs up to the fly-by-wire team for getting this all working, and I know that it has been a major feature that all of us have wanted to see in the aircraft since the initial fly-by-wire A320NX release. It's now finally here and it's all working, and if I just speed the video up here, you'll see just how well this aircraft flies the entire entry and then goes ahead and enters the hold as we would expect it to. Remember, of course, guys, that this is only currently available in the experimental version of the fly-by-wire mod, so if you're still flying the stable build or the developer build, you won't have this working yet. One final thing to let you know about is how to delete holds. So obviously we've got the Dane one still in the database. Press the clear button, and from there you will go and delete the second entry of Dane after where it says hold. Once we've done that, just go ahead and clear the flight plan discontinuity, and then the flight plan will be all tidied up and we'll be good to go. One other final thing to mention then before we go is that DME Arc legs are now working in the fly-by-wire mod. Again, the experimental version only. So if you are flying to an airport perhaps with a VOR DME Arc approach, these are now working correctly in the aircraft where they weren't previously. Another great achievement from the fly-by-wire team as they continue to improve on their LNAV. Once you program these approaches into the FMS, don't be too concerned if, like here on my navigation display, you do see it flickering occasionally. You can see the arc there, 1 minute, gone the next. That is purely because at the moment we are flying at 290 knots, far too fast to nicely make this DME arc flyable. As we slow down, activate the approach phase, etc., and get nearer to the airport, this will tidy itself up and fly the arc perfectly. So once again, I'd like to say a huge congratulations and thank you to the fly-by-wire team for continuing to give us what is by far the best freeware aircraft I think any of us in any flight simulator has ever seen. Please do leave a thumbs up, and of course if you have any comments on anything you've seen in the video today or have any comments regarding the hold function, then please do leave a comment down below and let me know as well what you think to the amazing work that the fly-by-wire team are doing. Remembering, of course, this is only in the experimental version. If you're new to the channel, please don't forget to hit the subscribe button and turn on that notification bell to be notified of future videos and, of course, our regular live streams. Thank you so much for watching. I look forward to seeing you all again very soon. Bye bye for now.